Great. So my name is Eli Asarian with Riverbend Sciences. I'm on the KBMP steering committee. I'm going to be emceeing our last little session of the day today. So our first speaker is Shahab Araghinejad, or you'll tell us how to pronounce your last name. Sorry about that. And he's going to be updating us on the State Water Board's modeling efforts on the Scott and Shasta River watershed. So glad to hear that. Go ahead, Shahab.
Sure. Thank you, Eli. I just turned off my camera. And let me share my screen again. So Eli, would you please confirm, do you still see it in the presentation mode?
Back to notes view again.
Now?
There we go. That's good. That's great. Yeah.
Okay, thank you. Well, hello everyone. My name is Shahab Araghinejad. I'm with the Instrument Unit, Division of Water Rights, the State Water Resources Control Board. And in the next 15 minutes or so, I'm going to talk about the ongoing water board efforts to develop models for the Scott River and Shasta River watersheds, as well as giving you a timeline for when the models will be finished and will be ready to be shared with you all. And I'm assuming that you hear me well. Is that correct, Eli?
Yes. Sounds great.
Okay. So to start my presentation, I go with the directives. Well, the Instrument Unit was created in 2014 to work with CDFW to implement this element of the California Water Action Plan. As part of that effort, the board initiated development of in-depth hydrology and water resources analysis in the Shasta River watershed, which is one of the 5 watersheds originally selected as part of the Water Action Plan effort. Furthermore, the governor's May 2021 drought declaration directed the State Water Board and CDFW to protect fish in the critical systems of Shasta River and Scott River watersheds. More recently, in January 2024, the governor issued the salmon strategy directing California Department of Fish and Wildlife to collaborate with other agencies like the California Natural Resources Agency and the Department of Water Resources to support salmon recovery in California. And in October 2024, the board adopted resolution number 2024-0036, directing staff to develop a scientific basis report and economic analysis for longer-term baseline flows in the watersheds. Well, while hydrology and water resources modeling efforts of Shasta River watershed started before the major drought of 2021, the Instrument Unit and related modeling efforts of both the Scott River and Shasta River watersheds became and has remained a primary focus of the Instrument Unit's workload since 2021. Well, major models under development for Scott River and Shasta River watersheds. The Scott River watershed is the home of the Scott Valley, an agricultural groundwater basin, and an important spawning and rearing habitat. The Shasta River watershed also supports both agricultural operations and the broader ecosystem, including salmonids. Therefore, the Water Board's main purpose of modeling is to provide information and to evaluate implementation scenarios that consider all beneficial uses of water, including water for fish and agriculture. To that end, an integrated surface water, groundwater, and water allocation model allows the board to assess various water management scenarios in the context of a variable hydrology, such as flows in wet, dry, and moderate years. This presentation is going to talk about these 3 types of modeling and how they fit together in an integrated model. First, it examines the Scott, then the Shasta models. Let's have a very quick look at the Scott River watershed. The Scott River flows south to north to join Klamath River. The Scott River has 12 tributaries, mostly in the west of the watershed, as you see in the map. The Scott Valley includes almost 10% of the watershed, as highlighted green in the map. There are more than 2,000 agricultural fields in the Scott River watershed. Field size Field size is the smallest scale of the watershed that is evaluated through the hydrologic models, as will be discussed in the next slides. Well, before I start talking about the technical aspects of the SCOD and Shasta models, let me demonstrate how various models are combined as the components of the final integrated model in the Shahab River watershed. This slide also acknowledges the technical teams working on each component of the integrated model. Well, looking at this slide, you will see that we have various components as the sub-models of the integrated model called integrated hydrogen water allocation model for the Shahab River watershed. Let's start from this on the left from this gray circle showing the regression-based stream flow estimation, which has been developed by UC Davis. UC Davis has also developed two other models, a water budget model and a groundwater model using mud flow. A combination of that regression-based stream flow plus water budget model plus mud flow is called SWRCB, or Scott Valley Integrated Hydrologic Model, or groundwater and statistical-based surface water model. Well, under the contract that the Water Board has with UC Davis right now, we are trying to replace this regression-based stream flow estimation with a physically based surface water model called PRMS and being underdeveloped by Larry Walker Associates. So if we combine this PRMS plus that water budget model plus that water mud flow, it gives us a model called SWRCB plus PRMS. That's how we call it for now. In addition to that, we are developing a water allocation model, which is being developed by Stockholm Environment Institute, or SEI, and an integration of this water allocation model and the groundwater and physically based surface water model, or SWRCB plus PRMS, gives us the integrated hydrogen water allocation model, as you see, as the purple circle in here. Well, let's focus a little bit more on the groundwater and surface water model in the Shahab River watershed. This slide reviews the basis of the Shahab River watershed groundwater and surface water models. The modeling process is started by defining and calculating the daily water fluxes for every one of the 2,119 fields in the Scott Valley, as you see in the blue box in here. To calculate the water flux at each field, various data including land use, soil properties, irrigation type, water source, potential evapotranspiration, crop coefficient, rooting depth, precipitation, and stream flow are needed, again, as shown in the blue box in this slide. The water budget model estimates evapotranspiration, irrigation from irrigation wells and streams, soil water content, and groundwater budget, as shown in the green box in here. Well, the water budget model is set up for the Scott Valley fields, but the major stream flow input comes from the upper watersheds beyond the boundaries of the Scott Valley. Therefore, a precipitation runoff model is developed, PRMS, to calculate the stream flow for the water budget model. Please see this red box in here. Well, two major outputs of the water budget model, irrigation and groundwater discharge, are used as the inputs for the mud flow groundwater model. And finally, as shown in the pink box here, a combination of the presented water budget model, mud flow, and the surface water model, PRMS, is referred to as SWRCB plus PRMS, as I mentioned in the previous slide. Well, SWRCB has been successfully used as a groundwater model in the Scott Valley for more than a decade. I will discuss the SWRCB model more on the next slide. This slide quickly reviews the history of SWRCB development. As shown in this slide, the history of using SWRCB goes back to 2007 and 2009, when it was first created by UC Davis and the North Coast Regional Water Quality Control Board to support the development of implementation strategies for the Scott River Total Maximum Daily Load, or TMDL. SWRCB has also been used by the Siskiyou County GSA with a published report available at the link provided in this slide. Also, board staff hosted a workshop on SWRCB by UC Davis, and a link to the recorded presentation is provided also here. The green box shows the main changes and improvements the board is working on with UC Davis to update SWRCB. Those changes and improvements are extending the simulation time to cover the recent experienced droughts in the Scott Valley, updating groundwater parameters, adding surface water model, as I showed you in the previous slide, adding the PRMS to the SWRCB model, improving calibration of the model, new scenario runs, and getting feedback from water allocation model. Model for Scott River watershed. The map on the left shows the distribution of the points of diversion or water rights in the Scott River watershed. Regulating water is not possible without considering the distribution and priorities of these water rights. Therefore, a water allocation model, in this case, the water evaluation and planning or WEEP model, is being developed to bridge the gap between the hydrology of the watershed and how water rights, face values, and priorities, and minimum water requirements are considered under different potential water management scenarios. The map in the middle of this slide shows the user interface of the Scott WEEP model, with the water rights shown as red dots and links between points of diversions and places of use as green lines. WEEP includes an optimization algorithm that can be used to calculate an optimized allocation of water based on the basic needs, for example, water for human health and safety, water rights priorities, face values, and minimum flow requirements in case of water scarcity. The hydrology model SWRCB plus PRMS and the water allocation model WEEP exchange hydrology and water allocation results iteratively until the convergence of the results of the models. The convergence of the results here happens when SWRCB plus PRMS and WEEP both provide similar results of hydrology and water allocation for each specific scenario. The convergence is the process of back and forth input and output data exchange between the models until they provide accurate results for both hydrology and water allocation. Now I'm moving on to the Shasta River watershed. But please, since I don't see you, are you still following? Can you still hear me?
Yes. Yeah.
Okay. Now I move on to the Shasta River watershed. The Shasta River watershed is almost the same size of the Scott River watershed with the area of 794 square miles. Similar to the Scott River, the Shasta River flows south to north to join Klamath River. However, the water resources in the Shasta River watershed is more complicated to model than the Scott. The graphic on the right shows the schematic of the Shasta River watershed water resources, including Dwinelle Reservoir or Lake Shastina, multiple major diversions, a major canal from Dwinelle Reservoir to city of Montague, and major contribution from groundwater and springs. Also, immediate interaction between groundwater and surface water in the watershed and return flows from the agricultural users makes the Shasta River system a very dynamic system with changing water temperature along the river. These are some of the main features of the watershed that are considered in the modeling process. I'm not going through the details of this graphic here, but the main message of the slide here is for the Shasta River watershed, like the Scott River watershed, the concept of an integrated surface water, groundwater, and water allocation models is used, as demonstrated in this slide. Please see the highlighted green boxes, one for surface water, one for groundwater, and one on the right for the water allocation model, similar to the concept used for the Scott River watershed. However, the hydrology models used in the Shasta River watershed are different from the Scott River watershed models. The hydrology model in the Shasta is a combination of LSPC and mud flow models The water allocation model is the same as that used in the SCOT WEEP. The hydrology model is being developed by Paradigm Environmental, and water allocation model is being developed by Stockholm Environment Institute, SEI. Furthermore, because of the dynamic water temperature system in the Shasta River watershed, as a result of reservoir, springs, and return flows, a two-dimensional temperature model is being developed by Paradigm Environmental, as shown as the highlighted pink box in this slide. Water allocation model in the Shasta River watershed. This slide shows the distribution of water rights in the Shasta River watershed and WEEP model to support optimized water allocation for various scenarios in the Shasta River watershed. As discussed in a few slides before, the use of WEEP as a water allocation model helps us to consider the priority of water rights in allocating water during times of water scarcity. Furthermore, with a user-friendly interface, WEEP can help the board evaluate scenarios of interest by changing the water sources and sinks in the entire watershed. What to expect from the modeling results? Some potential benefits of these models are summarized on this slide and include information on unimpaired flows, including base and peak flows, and modeled flows that can be used to support missing historical flow data. The modeling results could also be used to develop or update water year or month types and support analysis of how water quality may respond to different flow conditions. Model results will also help the board evaluate different implementation scenarios, including impacts to water rights and local cooperative solution options. For example, modeling results could be used to evaluate implementation alternatives such as curtailment via the water rights priority system or other approaches developed by water rights users. Now, I'm going to give you an update about the timeline for release of draft model reports for public review and comment. As you see here, the Water Board aims to finalizing the models and reports for the major scenarios for public comment in November 2025. In November 2025, the models and reports would be shared with public and the Siskiyou County Groundwater Sustainability Agency, GSA, to receive comments. A notice of soliciting comments would be sent out once the models are published. Following the public comment period and any needed updates to the models, they will be submitted for peer review through the board's peer review process, which is targeted for ideally February 2026. The board plans to continue to integrate available data and information moving forward as resources allow. This is an example of published models and reports by the State Water Resources Control Board for one of the Water Action Plan watersheds, Ventura River watershed. The link to this webpage is provided for your reference if you would like to see the published information. Well, if you go there, you will see that, the various, like at least two different versions of the models before the comments and after the comments, all the comments that we received through developing that model and the responses to that comments and how we kind of revise the model based on the comments that we received. So this is a good example of how we're gonna publish the model and reports for the Scott River and Shasta River watersheds. A similar web page would be provided for the Scott River and Shasta River watersheds after finalizing the models based on the timeline provided in the previous slide. Now, I would like to thank everyone who contributed to the various steps of these modeling efforts by sharing data, information, and feedback. Also, a special thanks to UC Davis, Larry Walker Associates, and SCI for leading the Scott River watershed models, and Paradigm Environmental and SCI for leading the modeling efforts in the Shasta River watershed. I also would like to thank Siskiyou County GSA and Scott Valley and Shasta Valley Water Master District for their valuable contribution to the modeling process for both Scott River and Shasta River watersheds. And last but not least, a specific thank you to you all for being here today and for sharing your valuable time. Well, thank you everyone so much. This is the email address that you can contact us for any question or any update that you would like to receive about these modeling efforts. And also, when the models are ready and are finished, I mean, the first draft of the models, we would publish them in this link that is provided in here, based on the timeline that I provided you in previous slides. Well, thank you so much, everyone. I would be happy to answer your questions.
Let's see.
Please
And I'm going to
clarify,
turn on my camera.
I believe that the Scott Valley Integrated Hydrologic Model added a PRMS module to it, but the water board now is taking on a separate process to do that. Is that true, or am I not understanding?
Okay. Well, the major changes to I hope that I got everything from your question, but the major contribution and major changes regarding the previous version of SWRCB is a couple of things. First, as you said, is that surface water model incorporating with the SWRCB model. The second one, which is really important for me, is to incorporate all the data and information and experience that we got from the recent droughts. That's very important for the calibration of the model, because I believe that it was kind of a unique experience. If you look at the data, information, and everything that we experienced in last, let's say, 4 or 5 years, that would be a very good input for the model to be recalibrated. So recalibration is another major contribution to improve SWRCB. But the concept of the model, well, is pretty much the same, except in some of the calibration algorithms. So now UC Davis is considering more, let's say, benchmarks for calibration of the model. So we hope to get, I mean, the results that are more kind of representative of the hydrology status of the watershed. Not sure if I answered your question.
Maybe, but thank you.
No
So
problem.
we have an online question from Scott McBain. He says, will the model itself be made available for review in November 2025 in addition to the draft documentation? Like,
That is correct, Scott. We're going to share the models themselves in addition to the models report. And if you go to like our Ventura River watershed, which I provided as an example, you will see that, I mean, both models and model reports are provided there. The answer is yes. We're going to provide the models themselves.
Any other questions for Shahab?
Grant had his hand raised, he's down now.
Grant, do you have a question? You had your hand raised, but.
No, that answered it. Thank you, Shahab.
No problem.
Okay, thanks, Shahab.
Of course.